So in the surface environment lunar science session, we came up with 12 different science activities we wanted to look at, starting kind of at the top, not of this chart, but of the most distant from, from the surface, the space physics realm. There's interest in understanding space physics experiments, really understanding the environment at 1AU, and not just the solar wind, but also the idea of the Earth wind, depending on what phase the moon is in, and going through the magnetotail could have different effects as well. The second one is the galactic cosmic rays, solar energetic particles, and solar wind monitoring, looking a little bit larger out in the solar system. Bringing that down to the surface, these cosmic rays especially, but also the energetic particles, when they interact, they create secondary radiation from both the surface, from the rocks and from the regolith, but also from human structures. And so there's activities and experiments that should be done to measure those secondaries as well. Fourth would be the exosphere, starting with the permanent exosphere and also looking at transient exosphere events associated with natural and human-induced phenomenon, including micrometeorite bombardment and arrival and departures of rockets, etc. Continuing on the exosphere for rocket plumes, surface disruptions, and other human activities was another avenue we talked about. Six would be dust and plasma interaction. So recognizing that the polar region has a very complex plasma environment and surface charging plays a large role in the dust that's there, this would be experiments to look at the plasma and the electrons moving around the surface and above the surface and on the surface. The seventh is continuing with the dust, looking for horizon glow and monitoring both natural and human activities changes in different parts around base camp, which may have different dust fluxes, influence of micrometeorites again, and using a combined approach, so not just cameras, but also physical dust detectors, but for the cameras, including polarization. Eighth was calibrated cameras to monitor the wide range of surface changes that would be associated with activities, from everything from the astronauts moving around and the vehicles moving around to what the effect is after many diurnal cycles of these structures being on the surface. Ninth is monitoring how the regolith is modified and overturned specifically by human activity, including vehicles and that's vehicles would be spacecraft, arrivals and departures. And so this would be more of a physical experiment as opposed to the camera to look at how the regolith overturn is affected over time. 10th is the thermal environment, the natural thermal environment and the human-induced environment. And I mentioned this in the kind of introduction to Breakout 1. These are distinct and we want to understand both of them and they change over time. 11th is impact monitoring, and this can be done either through using seismometers, or one of the techniques that was described in the lightning session was optical fiber structures, and these can be used to gain information on the behavior of structures in response to these vibrations, as well as information about the impact population. And then 12th was actually the first one we discussed, and that was just what is the destructive effect of some of these very, very large return vehicle liftoffs initially, especially if you don't have landing pads or launch pads initially, and you're just doing this on the bare regolith. What experiments can be done to understand those effects early on and how imperative it is to get those landing structures created. We kind of put these into a number of different categories and identified some of the ways that they're uniquely enabled from base camp. The second part of our conversation was talking about what the required infrastructure and if crew is required to do it. And as we were discussing this, it sounded like most of the things actually have pretty similar. Some of the science experiments are fairly well known in terms of the power that's required, data that's required, and generally the biggest involvement from crew was the deployment phase, or if it needed to be replaced, having that as well. There were a few, we also got into a discussion about wireless communications and using more conventional communication protocols that are used on Earth, such as Wi-Fi or cellular networks, and how that could be enabling, especially for some of these more diffuse experiments. For example, the dust one in particular would like to be monitoring the dust at every place around the base as opposed to just one central dust monitoring location. One of them, the one involving the seismometers or optical fibers, would require significant infrastructure to deploy, including a large-scale rover such as the LTV. And yeah, I think that is about it for that. And then we are also taking the white paper signups as well. So I'm going to go ahead and put the Google Sheet information for Breakout 1. And if anybody has anything they'd like to add, you're more than welcome to sign on to the Google Sheet and add your comments or sign up for any of those activities if you'd like to. Indicate your interest in participating in a white paper. And that's all I have. So 3 minutes left. If there's any questions, I can take questions now. Or any additional comments from anyone who participated in the breakout and wanted to say a few more words. Okay.